All right, so some products, like I said before, we encounter can be differentiated by either method illustrated in the previous example. Others, you have to use the product rule. So unless otherwise instructed, you should use the product rule to differentiate all products in this section in order to gain experience with this important differentiation rule. Now, what you could always do is you could do the other one to check it, but really we should try using that product rule to do these. So with that said, let's do our first problem here. So we're supposed to repeat example 2, except with the new function. And basically, we're supposed to find the equation of the tangent line to the graph of f of x equals 3 and find the value or values of x where the tangent line is horizontal. All right, so first things first, we need to find f prime of x because that's just the first thing we have to do. So f prime of x is going to be what? Well, it's going to be our first, which is 2x plus 9, times the derivative of the second, which is going to give us a 2x. And then plus our second, which is the x squared minus 12, times the derivative of the first, which is just going to be 2. Now multiplying that out, that's going to give us a what? A 4x squared plus 18x plus 2x squared minus 24. Now we have a 4 and a 2, so it's going to be a 6x squared, and then it looks like minus 18, oops, plus 18x, and then minus 24. So that is our f prime of x. All right, so now what we want to do is we want to find the equation of the line tangent to the graph at x equals 3. So the way we got to do this is we have to find what f of 3 is, and we also have to find what f prime of 3 is. Okay, so what is f of 3? Because when we find that, that'll give us a point. When we find this derivative, and plug in 3, that's going to give us a slope. So if we plug in the point here, well, what do? Well, we're going to take 2 times 3 and then plus 9 times 3 squared minus 12. So that's going to be 6 plus 9. So that's going to be 15. And that's going to be 9 minus 12. And so it's going to be a minus 3. So that's going to be a minus 45. All right. So then that gives us the point 3 minus 45. Now, what is f prime of 3? The derivative. So what is the slope here of the tangent line? All right, the slope of the tangent line is we're just going to plug in 3 here. So it's going to be a 6 times 3 squared plus 18 times 3 minus 24. And so that's going to be 954. And that, so it looks like we're going to get what, 84? So that should be our slope. Now, if we want the equation of the tangent line for A, now all that's just to get to the point where we can do that. We're using our point slope form. So we're going to use y minus y1 equals m times x minus x1. Well, here is our x1, y1. Here is our slope. So we have y minus y1, well, that's going to be a minus 45, equals slope, which was 84, times x minus, and then we have a 3. Okay. And so that's a minus 40, plus 45. So if we subtract 45, we looks like we're going to have y equals 84x, and then that's going to be minus 297. And so that's going to be the line tangent to the graph at x equals 3. So I won't write all that down, but that's what that's going to be. So that's our equation of our line. Okay. Now, what else does it ask for? Find the values of x where the tangent line is horizontal. So that means where is the tangent line, or the this part here, where is that equal to 0? Well, that's going to be equal to 0 when? Well, at that point, it's going to be 6x squared plus 18x minus 24 equals 0. So that's going to be when it's equal to 0, it's going to be horizontal. I see that all those have a factor of 6. So if I multiply everything by 6, then I get x squared plus 3x and then minus 4 equals 0. If I factor that and set each one of those equal to 0, that will give me my points where x is going to be the horizontal at that point. So this is going to be what? X plus 4, x minus 1. So here x is equal to a negative 4. Here x is equal to 1. And so these are the 2 points where the tangent line is going to be horizontal, or basically your slope is going to be 0. Okay, let's do another one. I guess 2 more here. And so we're supposed to find the derivative. All right. So as I said, we should use our product rule. Again, it's first times the derivative of the second plus the second times the derivative of the first, and that's going to give us our f prime of x. And so here, f prime of x is equal to what? Well, what are we going to keep into place? Well, let's take that as our first, that as our second. Okay. Well, what is the derivative of that? Well, that's going to be a 40x to the seventh. Oh, wait. First is just that. So we just have 5x to the eighth. Now, the derivative of e to the x, well, that's just e to the x, remember? And now we take the second e to the x times the derivative of that. Now that's going to be the 40x to the 7. And that could be, one example of where we could stop. We could also, excuse me, we could see that there's an e to the x in both of these. And so we could pull that out. We both have a 5x to the 7th. So if we rewrote this kind of in the same form here, that would be a 5x to the 7th times what? Well, what's left over here is there's one x, and here is just an 8. So plus 8. And then we could put our e to the x back on the end. And that would be our derivative of 5x to the eighth times e to the x. So, this would be one answer. This would be kind of a factored into a different form, but kind of the same answer as well. All right, what about the second one here? Well, here, f prime of x is going to be equal to what? Well, again, I think I'm going to use that as my first, that as my second. So the first is x to the 7th times. Now the derivative of ln of x is 1 over x plus, now the first ln of x times the derivative of the second. Well, that's going to be 7x to the 6th. If we can get that x in there to look good, to close enough, we know what it is. So, all right. Now, what do we see? Well, we see that x will cancel one of those, and we have 6. And so now what we can do is then say, okay, well, there's an x to the 6th here, there's an x to the 6th here, so we have x to the 6th times, well, if we take that out, there's still 1, and plus, now we have a 7 ln of x. And that would probably be the form I would suggest putting it into, because we did factor that out. There is a really common factor of that x to the 6th that we can notice, and so that would be my form. I would leave it in there. All right, so let's stop there and we'll come back for more.